Welcome to the Digital System Design course. In last lecture, we have discussed different type of complements and how in binary number system as well as in decimal number system, how we can calculate the complement in a particular number system. We also have discussed two types of complement, that is primarily R's complement and R minus 1's complement, and how for a particular number given in a particular number system, the R's and R minus 1's complement can be calculated. We also have discussed what is the relationship between R's and R minus 1's complement, and we also have discussed that 2 times complement if taken, the original number we will get. Now in this lecture we are going to discuss how complements are going to be used to perform the subtraction process in the context of digital computer systems. That means how subtraction is going to be done using complements, R's complement as well as R minus 1's complement. So we are very much familiar with the concept of subtraction using borrow concept. That means if the number is to be subtracted is higher than the number, then we take the borrow from the subsequent left hand side bit or number and then do the subtraction, and then in the same way we go forward. But here what we are going to represent is, suppose we have two numbers A and B. A is going to be called as minuend and B is subtrahend. So B is going to be subtracted from A. So what the earlier concept we have used, if a number B is larger than the number A, suppose we have 11 and we are going to subtract 2 from 11. So this first digit 1 is going to be less than this 2. So we will take borrow from left hand side digit and then this number become 11, we got 9 and here 0 is there. So this is the concept of borrow and then complete the subtraction process. But the problem is using this particular concept, if this particular logic or concept is going to be implemented in digital systems, digital computer systems especially, with the help of digital hardwares, that means some gates, transistors will be there, then this particular process will be quite complex and less efficient also. That means this whole process. So we are going to look for the other methodologies which are going to be efficient and also going to be required less complex hardwares to implement the process. The process in question here is subtraction. So what we prefer? We prefer complements. That means we use complements, either R's complement or R minus 1's complement to complete the subtraction process. How the thing is going to be happen? Two numbers A and B. B is going to be subtracted from A. So we know that addition process is going to be a simpler one in digital systems, digital hardwares also. So we convert this subtraction process in addition, like if you are going to B given number, convert it into minus B, that means complement of B. If you are going to take the complement of the B, that means subtrahend number, the number which is going to be subtracted, and then simply add it to the A, we will get the A minus B. Simple concept is, we have number A minus B, B is going to be subtracted. So what we will do, we will convert this process into addition by making complement, either R complement or R minus 1's complement of this number B, that suppose B dash is there, and then we add this number, provided some post operation adjustment are needed, like we have to discard the carry if it is going to be generated in the end result, or some other adjustments are also there, we will discuss in subsequent slides. So for example, we have to subtract 5 minus 7, that means this is the operation we want to perform. 7 minus 5, obviously the numbers are in decimal number system, the expected answer is 2 only. So by using complement, how we can do, keep the first number as it is and then take the R's complement. Here we have used R's complement, that means in decimal number system this is 10's complement. So 10's complement of 5, you remember that 10's complement of 5 will be 9's complement plus 1, that means R's complement is equal to R minus 1's complement plus 1. So 5 9's complement will be 4 and plus 1, that is 5. So we get 10's complement of 5 is equal to 5. Then we simply add the number. We got 12, but please note that some adjustment, that means we have to discard the carry if it is generated. So we discarded the carry and we left with the answer which is right only. We got the number 2. The subtraction of 2 n digits unsigned number. Please note that we talked briefly about this signed and unsigned numbers in the previous lectures, that in digital computer systems some arrangements are needed to represent the number with its sign, while in day to day we use this particular sign for negative numbers, that's minus. But in digital computers, the left hand side LSB, that particular bit is reserved for the sign. If it is 1, then the number it represents with minus sign. If it's 0, then number represent it's a positive. So the steps are: add the monument to a to the r's complement of subtrahend b, that means a plus a minus b we are going to implement. So a plus b's complement of r or r minus 1s, both can be there, complement of b. So this is what we are going to do. Add the monument a to the r's complement of subtrahend b. The first case is if a is greater than or equal to b, the sum will produce an end carry. That means if I am going to perform the first previous example 7 5, that's a a, that's a b. So a is greater than b, and that's why end carry is going to be generated, and we have to discard the carry. If a is less than b, suppose number is less than 5 minus 7, here a is less than b, so does not produce an end carry, but please note that the end result is also not accurate. What we have to do to obtain the right answer in familiar form, take the r's complement of the sum and place a negative sign in front. That means what you have to do, suppose 5 minus 7 we have to do perform. So take the r's complement or r minus 1's complement of the 7, add with this particular number, and no carry is going to be generated. But to get the right answer, you have to put the sign minus and then take the same complement, either r or r minus 1's complement of this particular answer, and you will get the right answer. We will do this particular one with some example also. So this is the first example. Using 10's complement, we want to perform this operation, this subtraction, 72532 minus 3250. Please note that here case 1 is going to be applicable, the number a is greater than b. That means end carries we are going to expect, the end carry is going to be generated, and we have to discard the carry. So the process, we are very much sure that we are going to take 10's complement of number 3250, that means number b, and then we are going to add with the given number a, and the carry is going to be generated, which we are going to discard to get the right answer. So a minus b, this is the given problem. We are going to take the 10's complement of this number. Before that, please note that we have to ensure that both digit on which the operation is going to be performed must have same number of digits. Please note that, otherwise some other confusions will be there. So please ensure that the two numbers must have equal number of digits. So the first process, the first step, what we have ensured that both two numbers must have same equal number of digits. So this number a having 5 digits, this one only 4 digits, so we have added 0. It doesn't make any change to the overall value of the number, so it's a 03250. And then the second step, we are going to take the 10's complement of the number b. So number is 03250, and we have to take the 10's complement of this number and then add it to the a. So to get the 10's complement, what I will do, first I will take the 9's complement. So 9's complement, that means each digit must be subtracted from 9. So we will get 9, 6, 7, 4, 9, and then this is 9's complement, please note that, and then we are going to add 1 to get the 10's complement. So the number we will get 96750. and this is what we got here. So then this number A is going to be added with this particular one. Now please note that what is the concept of AND carry? The both number which we have started with, both number contains 5 digits each, but the AND carry has, the end result has 6 plus 3, 6 digits. So that means this MSB is called as a carry. And then the first step, make the equal number of digits in both number, take the tens complement of the second number, add it to the A, then check the number of digits in answer. If it is more than the number of digits in each A and B, discard the carry, and the final answer will be 69282. You can also verify this particular answer with the normal borrow concept. 72532 minus 3250, 2 13 8 4 2, then 11 282, then it's a 9 and it's a 6, 69282. So you should also understand that whatever the procedure we are going to implement, the answer will be same even with the normal borrow concept which we used earlier. Now the same number, but this time we are going to take the case B. That means now A is less than B, and we remember that in this particular case no carry is going to be generated, but to get the right answer we have to put minus first and then take the tens complement of the answer which we got in previous stage. So the first thing is we have to make same number of digits. So 3250 we have to add 0. So we got 03250, and the second number as it is, 5 digits are there. Then we are going to take the tens complement of this number 753532 and then add it to the A. So A is same only, and then we are going to take the tens complement of 72532. So first we are going to take the nines complement, subtract each digit from 9. So obviously we will get 2, 7, 4, 6, 7 plus 8 plus 1, and that means this particular digit will become 8. So we will get 27468, 27468. Now we have added this particular one. Please note that this answer is not going to be on the expected lines. To get the right answer, what we have to do, since no AND carry is generated, so the final answer will be minus tens complement of the number what you got here, 30718. And if I am going to take the tens complement of 3718, first I am going to get the nines complement. Nines complement will be 6, 9, 2, 8, 1, and then plus 1. So this digit will become 2. So you will get 69282, and the answer is going to be with minus sign. And you can verify the same using borrow concept also. That means 3250 minus 72532, and you will get the answer 69282 by the simple borrow concept also. What we have seen here, that depending on the number of digits we have to make them equal, and the two cases may arise. If number A is greater than B, then a carry is going to be generated, and we are going to discard the carry to get the right answer. In the second case, when A is less than B, no AND carry is going to be generated, but to get the right answer we have to again take the tens complement of the number which we got in previous stage and put a minus sign. We will get the right answer. Now in the previous slide we have seen R's complement in decimal number system, that means tens complement. Using tens complement, how subtraction can be performed. Here we will see two numbers are there and we have to perform subtraction operation using R's complement in binary number system. Please note that R's complement in binary number system will be obviously 2's complement. So two numbers, again please note that these are the binary number system, so numbers are only limited to 2 digits, 0 or 1. So first we are going to perform x minus y and then y minus x. Okay. First case, x minus y, please note that 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Both number have same number of digits, so we don't have to worry about equal number of digits. So x minus y, I am going to take the 2's complement of this number. You please note that taking 2's complement, first take that 1's complement and then 1, then add 1. So 2's complement of this particular number, 1, 4 times 0, double 1. This number will be simply 1's complement, change 1 to 0 and 0 to 1. So obviously the number will be 0, 4 times 1 and 0, 0, and then add 1. So the number will be, this bit will be going to change 1. So 0, 4 times 1, 0, 1, 0, 4 times 1, 0, 1. This is what the 2's complement of the given number y, and then simply add these two numbers using binary addition. So we got this particular one. Please note that now in this particular answer, 1, 2, 3, 4, 5, 6, 7, 8. We got 8 number of digits, and this is very much clear that we started with 7 number of digits in each x and y, but in the end result we got 8 number of digits in the answer. That itself says that we got an AND carry, and then that's why AND carry is generated. Discard it and the final answer will be everything except this particular digit, and then we got 0, 0, 1, 0, 0, 1, and this is the answer. But in the second case, started with x and y, but here y minus x we are going to perform. Both number have same number of digits, so we don't have to bother about the equal number of digits, they are already. Now this time we have to take the 2's complement of this number x. So 1, 0, 1, 0, 1, 0, 0. The number will be simply first 1's complement, then 0, 1, 0, 1, 0, 1, 1, and then simply add 1. If I am going to add 1 here, 1, 1, 0, carry 1, again 1, 1, 0, carry 1, 0, 1, 0, 1. So what the answer, what the 2's complement we got, 0, 1, 0, 1, 1, 0, 1, 0, 1, 1, 0. This is the 2's complement of the number x, and we simply add this particular one. Please note that here again 1, 2, 3, 1, 2, 3, 4, 7 number of digits. This is clear that no AND carry is generated. So if no AND carry is generated, that means answer is not on the expected lines. So what we have to do, we have to take the first minus sign and then 2's complement of this particular number, and the number is 1, 1, 0, 4 times 1, 4 times 1, and if I am going to take the 2's complement of this number, 0, 0, 1, 4 times 0, and then add 1 here. So I will get 0, 0, 0, 1, 0, 0, 1, 0, 0, 1. Please note that these two answers, this one and this one, both are going to be same, but only the difference is minus sign. Likewise, if I am going to ask that 7 minus 5 is equal to 2 and 5 minus 7 will be minus 2. This is the simple understanding which help you to verify the answer, whether you got the right answer in both cases or not. Simply you can verify that in the case of AND carry or in the case of no AND carry, whether the answers are going to be same if the number has been operated at x minus y or y minus x. Logic says that, simple logic says that answer will be same except the negative sign, and this is what we got, same number or only difference is minus sign. Then the next thing we have discussed till now, that how complements, R's complement in decimal as well as in binary, how it's going to be used to perform the subtraction operation. Now the second class, that's R minus 1's complement. That means here again two cases will be there. In case of binary, we are going to make use of 1's complement, and in case of decimal we are going to make use of 9's complement. That means Now we are going to study that how using r minus 1's complement, that means 1's complement and 9's complement, the subtraction can be performed. So now the number is x and y given like this one. Again we have to perform the same operation, x minus y and y minus x, but this time it's a in binary r minus 1's complement, that means it's a 1's complement. A little bit change is there, please note that change. The number, equal number of digits, 7 each, 1, 2, 3, 4, 5, 6, 7, here also same 7. So we don't need to worry about equal number of digits, only we are going to take 1's complement of this particular number. It will be quite simple, only you have to change the digit from 1 to 0 or 0 to 1, then you will get 1's complement. So we have simply changed this number, this will be the 1's complement of the number 0, 4 times 1, 00, and then simply add with the given number x. This we got. So the number is 1, 2, 3, 4, 5, 6. So end carry is generated because here 8 number of digits are there. Add it to the LSB. We have to add the number 1, 00, 1, 4 times 0. Since we started with 7 digits each in x and y, but we got 8 digits in this particular one, that means this one is the end carry. Here in the r minus 1's complement, in contrast with the r's complement, in that we have discarded the carry, but here we are going to add the carry. And please note that why we are going to add this particular one, because if you have noted, r minus 1's complement is 1 less than the r's complement. That means r minus 1's complement of a particular number is going to be r's complement plus 1, and this is how we get the r's complement. This is minus 1, less than. Okay, so this and carry is going to be added in this particular one. How? 1, 00, 1, 4 times 0. So this is the and carry. I am going to make here this particular one and add. So 001, 3 times 0 and 1, and this is what we got. 001, 3 times 01. Again repeating, you have to make note that in r's complement, whether in tens or whether in 2's complement, we have to simply discard the carry. But since in r minus 1's complement it is 1 less than the r's complement, we have to add the end carry if it is generated to the LSB of answer, and this is what we got. Now the second part of the question is y minus x, again using 1's complement. So this time I am going to take the 1's complement of this number x and simply change 0 to 1 and 1 to 0, and we got the number this one. Please note that here no end carry is generated. 1, 2, 3, 4, 5, 6, 7. 7 number of digits are there. So the final answer will be similar to the process what we have followed in r's complement. Take minus, keep minus here, and then take again the 1's complement of the number, and this is what you got. Again you please note that 001, 3 times 01, 001, 3 times 01. That means whether we performed x minus y or y minus x, the number, magnitude of the number is going to be same except the sign this one. So in this way you can verify the answer if you are going to do such type of questions by yourself only. Thank you.